All right, so y'all 9.3. Nine point three deals with exponential functions. All right, so now the first thing they want us to learn in this section is what we call an exponential expression. And they're using what we call Euler's number. And Euler's number is that little e, and you'll see this on the calculator. Let me pull mine out. So you'll see a little blue E above the division sign on your calculator. So if you hit the second button and then the division, it'll pull that E on the screen for you. So I'm going to go to my calculator and show y'all. All right, so it's right over here on the division. So you would hit second and then the divide. That'll put the little E on your screen. So I'm just going to show you what E actually represents. It's sort of a constant like pi. So if we hit enter, you'll notice that the E is approximately 2.71. And I'm just going to round it out about 4 decimal places. Whoops. Also, I want you to see on the calculator, another place where the E is, if you'll hit the second button, and then on the left side by the 4, there's an LN button. Notice right above it is a little E with an X. If you hit that one, that brings the E up with an exponent, and that'll sort of help you do the problems I'm about to do, okay? So let me go back to my pad. All right, so E basically is equal to 2.7183. So in this section, the first thing they want us to do is they want us to use a calculator to approximate each expression to 4 decimal places. All right, so they just want me to see what the value is of these expressions to 4 decimal places. So I'm going to start with E to the third. So the little squiggly equal signs like that means you're approximating your answer or rounding it off, okay? So on my calculator, I'm going to go to my screen again on my calculator. So to do E to the third, I'm going to clear this. I'm going to use the E over here by the LN. So I'm going to hit my blue second button and then the LN button. So now all I got to do is put in my 3 for my exponent. And when I hit enter, remember I want this rounded off to 4 decimal places. So that's going to be 20.085. So the next place is a 5. Since there's a 3 behind it, I would leave that as a 5 for my 4th decimal place, okay? So that now rounded off to 20.0855. All right, then they want us to play with negative exponents. So E to the negative 3.45. So remember, negative exponents make numbers look like fractions or decimals, okay? So let's go punch that one in. So I'm going to use the second LN to get my E with the exponent. So our exponent was a negative 3.45. And when we hit enter, see how that decimal is less than 1? So with negative exponent, it's always going to be less than 1 for you. So that'd be what? 0.03, 1. So I'm looking at the 7. Since that's the 4 behind the 7, I'm going to leave that a 7. So I'm rounding that off to 0.0317. They're sort of showing us this E because later on in, I think it's 9.7, we deal with interest type problems that use the little E in their formulas. All right, y'all. So now we're going to learn about exponential graphs. Some properties about exponential graphs. And these exponential graphs will look like f of x equals a to the x. So before, when we did graphs that looked like this, our variable was the a. So that would have been our x, and then we would have had something like a 2 for the x squared graphs or a 3 for the x cubed graphs. Well, now the variable is going to be the exponent, and the base will remain the same for each of these problems, okay? So things we know about exponential graphs. They cross through the point. Zero, 1. And the reason they pass through the point 0, 1, because if the exponent is a 0, any number, I don't care what that number is, raised to a 0 exponent equals 1. So that means anything that's exponential is going to pass through that point. Second thing we know about these graphs, they're continuous. What I mean by continuous is they have no places where they're undefined. So they'll never have a vertical asymptote, or they'll never have a hole in the graph. So the domain of a exponential graph is from negative infinity to positive infinity. Okay, so any value I put in for that x is valid, and I'll get an output for my y values. Horizontal asymptote. Would be y equals 0, which is the x-axis. So over time, one side of these graphs usually tries to get to the x-axis, okay? Another property of these, the range. The range of an exponential graph will go from 0 to positive infinity. It can equal 0 because it never can get to the x-axis, okay? So that's why the 0's in a parenthesis this time and not a bracket. All right, y'all, so that's some properties of my exponential graphs. So we're going to graph one of these so that you can see what I'm talking about on this, okay? All right, so we're going to graph y equals 2 to the x. So I'm going to come over here and draw my graph. I'm going to go about 8 on these y's. All right, so I need to pull the camera down, it looks like. All right, so I'm just going to make a table up and find some values to graph. And I'll probably do quite a few points to show y'all the asymptotes and my graph heading off towards infinity. So the first x I'll do, I'm going to do positive x's on the right side first. So I put a 0 in for the x. That gives me 2 to the 0, which equals 1. So any base, I don't care whether it's a 2, 3, 4. If you put a 0 for the exponent, you'll get a 1. So my 0.01 is right on the y-axis. And I'm going to put a 1 in for my x. So that gives me 2 to the first power, which is 2. So anything to the first will be itself. So over here at 1, we go up to 2. Well, I'm going to put a 2 in here. So if I put a 2 in for the x, that gives me 2 squared, which is what? 2 times 2, which will give us 4. Well, notice over here at 2, I'm up at 4. You can sort of see that I'm going to get me a little curve on that side. So let's go one more. Let's go to a 3. That would be 2 to the third power. So 2 to the third power would be 2 times 2 times 2, which would be 8. So over here at 3, we're all the way up at 8. So it's going to start sort of curving pretty quick, just like that. If you ever seen the graphs of the coronavirus, they start increasing pretty quick. Because y'all, if that was a 4, 2 to the 4th would be 16. So at 4, I would be all the way up here at 16. So it sort of starts doing what we call the doubling, okay? Let's look at what happens on this negative side. If you put a -1 in for that 2, you get 2 to the negative first exponent. So we make exponents positive by putting the expression under a 1. So to make that exponent positive, I would put that whole thing under a 1 and change the exponent to a positive 1. So negative exponents are really fractions in disguise. All right, then that 2 to the first on bottom just gives me 1 over 2, which is a 1/2. So at -1 here, you're at a 1/2. So I'll do you one more to let you see what's happening. So that's a -2. If I put a -2 in for that x, I get y equals 2 to the -2. And y'all, the calculator will spit out these negative exponents all day long. But the first thing I'll do, make the exponent positive by putting that under a 1. Now on the bottom is 2 to a second power, which gives me a 4. So this ends up being a 1 over 4. So 1/4. So at -2, we're down here at 1/4. So what's going to happen over time, this left side is going to try to get down to that x-axis, but it never reaches it. The right side, they're going to start growing exponentially towards positive infinity. Okay, so our exponential graphs, when you do math lab, are going to have that sort of upward curvy shape, okay? Oh, y'all questions on that? So let me zip that on the calculator real quick. So I'm going to go to my y equals, and let me clear this. So we had 2 to the x. So I'm going to push my base 2, use my upside down caret, the v, and then put in my x. So we're going to go graph that. So there you go. Notice the left side tries to get to the x-axis, and the right side is heading off towards positive infinity. So let's go look at that table by hitting second graph. So notice on the left side, the more negative you get, the closer to 0 my values are. Now let me go to the right side. At 0, you get 1. All of them are going to do that. And then watch it start doubling. 2, 4, 8, 16, 32. It starts doubling exponentially, okay? But they're not too bad, especially with the calculators these days. All right, so let me show you one that has the same shape, but it heads in an opposite direction. So watch this one. I'm going to do y equals 1/5 to the x. So y'all want to make me an x and y table. And then let's make our little graph. I'll probably go out about 5 on this one. All right, so like I said, I'm going to use 0 because 1/5 to the 0 is still going to give you a 1. So at 0, we're still at 1. But watch this. If I put a 1 in here, that gives me 1/5 to the first power. Well, anything to the first power is itself. So at 1, I'm down here at 1/5. Well, let me do one more. How about a 2? If I do a 2, that'll be 1/5 squared. So you square both numbers. 1 times 1 is 1. 5 times 5 is 25. So that gives you a 1/25. So that's pretty small over here at 2. Woo, that's barely going to be above that x-axis because you're starting to get really close to 0 going to the right. But it never will get to 0, so it's going to make its horizontal asymptote headed out to the right this time. So let's see what happens with these negative numbers. So the thing about fractions, when they're raised to negative numbers, you're still putting them under a 1. But y'all, when you put a fraction under a 1, you're basically flipping it so that this gives me a 5 to the first power. Change the exponent to a positive 1 now. So fractions, we flip and change the sign of the exponent. You know, 5/1 is 5. And 5 to the first is 5 still. So at -1, I get a positive 5. So over here at -1, I'm up at positive 5. So I'll show you one more on that. If this was a -2, what would happen? So that would be y equals 1/5 to the -2. All right, make the exponent positive by flipping the fraction. and changing the exponent to a positive 2 now. So basically now what we got, 5 over 1 is 5, and 5 squared gives you 25. So look here, at negative 2, you're way up here at 25. Too far for me to draw on my graph, but you can tell it's going to come in from this side, go down, and then follow our asymptote as it goes out towards infinity. So we'll say fractions have the opposite graph shape, okay? All righty, y'all. So then we're going to look at transformations. We did this back in chapter 7 before y'all took my second test. Y'all did transformations where we moved the graphs up and down, left and right, and we reflected them across the x-axis. So we're going to add one more move in this section, and that's going to be a reflection across the y-axis. So these are our transformations. All right, first one is still the same, vertical. So those would look like f of x equals a to the x plus a b. So they're adding a number at the end of our function. If b is positive, the graph is going to move upwards. If the b is negative, the graph will move downward. So if I add a number at the end, it's going to move me up. If I subtract a number at the end, it's going to move me down. Horizontal, which moves me left or right, that'll look like f of x equals a to the x plus c. So now I'm adding the number to the x. If the c is positive, you know, it was the same thing with the horizontals in chapter 7. If that c is positive, this graph is going to move to the left. And then if the c is negative, that graph will move to the right. So very similar to chapter 7. Next move was reflecting over the x-axis. So that'll be f of x equals negative a to the x. So all they did was throw a negative in front of my base, and that's going to flip me over that x-axis. And y'all, the new move is to reflect me across the y-axis. That'll be in this form, f of x equals a to the negative x. All right, and I think there's one more I'm going to show y'all. This is what we call changing the magnitude of it. If we have something like this, b times a to the x. If b is a number greater than 1, then the graph increases by magnitude of b. So say b was 5. You would evaluate your function, and then whatever answer you get, you're multiplying by 5, which is going to make that graph 5 times bigger than it should be, okay? They're not going to kill you on that, but I did see it on our homework, so I wanted y'all to know what was happening with that, okay? So I'm going to send out a video later on how to do these on MathLab, but and I'll sort of tell you what I'm doing on here if I was using MathLab, okay? Because MathLab's picky as far as doing these. So my first one I want to do is f of x equals 2 to the x minus 2. So in MathLab, you start with the graph. Of y equals 2 to the x. Now, MathLab already has that x there. All you're putting in is the 2. So whatever your base is going to be the base that you got to start your function with. Then you tell me what this is doing to it. So I'm going to shift. So up here we said that's in this form. If that c is negative, which my 2 is negative, it's going to move me to the right. So shift right 2 units. And y'all, that's the only move I got on here. So some tricks on MathLab. You're going to start out by choosing the exponential tool. Once you choose the exponential tool, click it on the graph anywhere. It don't matter where you click on that graph, it'll put it where it needs to be. So once you choose the exponential tool, click it on the graph, it's going to open up a little box over there. Just like it did back in chapter 7. You have to change the base. By default, they got an E down there for Euler's number, but our base has to match what we got on our problem. So you need to physically change that base down there to a 2. Now, since mine went right 2 units, I would find the horizontal slider. You know, the horizontal slider, I would slide it right until I got it on 2. Okay, so choose the exponential tool, choose your base, and then move the slide controls. Now you'll also know if I got to do any of the reflections, it'll have little boxes you check for reflecting it over the x-axis and the y-axis, okay? All right, and then let me show you on the calculator if you wanted to. You can go to your y equals. So mine was what? Y equals 2 to the x minus 2. So we said that shifted me left. Shifted me right 2 units. So when I graph this, look how it went to the right on all the values. Okay, it's not actually crossing through the 0, 1 now since it shifted right. It's over here at about 2, 1 is now that point, okay? So they're not too bad once you get on that calculator. All right, so let me do some more of these moves for you. How about f of x equals 4 to the x minus 7? All right, so you would start with y equals 4 to the x. So you're always going to start with your base. Now remember, once again, MathLab puts the x's on here for you, so you just put in the 4. Now that -7 is at the end. So we said a while ago, if our b at the end was negative, it's going to move me down. So this would shift down 7 units. So for that one, MathLab, choose your exponential tool. Click anywhere on the graph. It's going to pop up the little box. On the little box, you got to change your base for this one to a 4. And then let's see, we went down, so we would do our vertical slider to what, a -7, since we went down 7. Once you change your base, move that to -7, it's going to shift the graph for you and be done. All right, y'all, f of x equals 3 to the 1 minus x plus 2. All right, so if you want to, for this problem, I usually like them x's first. So I'm going to rearrange the 1 minus x and make that a -x plus 1, and then bring down my plus 2. I just rearrange the order so the x's are always first on the exponent. So now we're going to start with y equals 3 to the x. I don't care if that exponent's negative, it's always going to start with a positive x up there, okay? All you're putting here is your base of 3. Now we'll look at what the shifts are doing. Where are we at? So that's a +1. That +1 is going to move me left 1 unit. So shift left 1 unit. That negative in front of that x, well, we said if the exponent was negative, it's going to reflect you across the y-axis. And then that +2 at the end, when you got a 2 at the end, it's going to move me up 2 units. Okay, so a lot going on in MathLab. So in MathLab, choose the exponential tool and click anywhere on the graph again. It's going to pop open the box. First thing we'll do, my base needs to be a 3. So my base down here needs to be a 3. So my first move, I went left 1 unit. So horizontal, you need to move left to a -3. I reflected across the y-axis. So you'll see a little box down here that says reflect over the y-axis. Check that. And then it went up 2 units. So that would be my vertical. Move that to a +2. Once you put all your moves in, save that and be done. So some of the trick is just keeping up with all the moves they're doing, okay? So let me see my chat's lighting up. Oh, this got doing this probably 6 or 7. Hey, y'all, they're not too bad. You can graph these, remember? Graph them on a calculator and see what's happening to them. Are they moving right? Are they moving left, up, or down, okay? All right, so I'll show you one more of the tricky ones. And I'll actually let y'all help me on this one. F of x equals let me see what's happening here. Which one did I just do? Okay, so I'm gonna do this one. F of x equals 2 to the x plus 3 minus 4. So start with y equals 2 to the x. So I'm going in order. So y'all tell me, what is the positive 3 doing to my graph? Since I'm attacking that exponent. So definitely moving me. Let me see what y'all said. So remember, those ones actually are opposite. You think it's going right, but it does really goes to the left. So this one shifts left 3 units. So remember, the left and right are always opposite what you think. So now what's the 4 doing at the end? And it's negative. So it's going to shift me what? Shift down. There you go. So it will shift me down 4 units. So on MATLAB, choose the little exponential tool, and then you'll move your horizontal to -3, your vertical -4. Okay. So we'll end up with a little algebra. How about that? Since y'all don't like graphing too much, we'll show you them formulas I was talking about. And these are sort of what I call investment formulas. So let me give you a formula and then we will explain everything about it. A of t means we're going to use t as a variable because that represents time. So let me write this whole formula down. You got p parentheses 1 plus r over n all raised to the n times t. So y'all check this out. Have any of y'all taken mathematical reasoning before you did the college algebra? Now I know a few of y'all did because I had y'all in my class. So we use this formula in mathematical reasoning class. So let me explain what's going on. A of t, that's the amount at any time t. So how much is in your account? P. P is your starting amount, which we also call your principal. So it's your principal, which is also your starting amount. Then we got a 1. R is your interest rate. Now remember, interest rate's going to be like 5%. I can't put 5% in my formula. I got to turn the interest rate into a decimal form. So interest rate has to be in decimal form and not percent, okay? And then y'all, the last thing up here is my T. Well, no, that's not the last thing, but T stands for time in years. So let's see, the only thing I got left is the little n. N represents the number of compounds in a year. So words that we'll use on compound. See if y'all got these. Semi-annually. How many is that a year? Perfect. That is 2. I might use words like quarterly. How about quarterly? 4. There you go. Monthly. Well, you're on the road, Jordan. So there's 12. Yearly. Yearly would be, what do y'all got? A 1. So perfect on that. Y'all got that. Yearly would be a 1. And then daily. 365. So there you go. So they'll use them kind of words when we describe our number of compounds, okay? Now, this is a section when you're going to love that calculator. I'm about to show you a trick when I find out the values they want. So first, let me write this down. Suppose $57,000 is invested at 5.5% interest, compounded quarterly. They got 2 parts of this. A, they want me to find the function for which the amount grows after T years. So find the function for the amount the investment grows after T years. So I'll say this, they just want us to find the formula that we're going to use. And then B, they want to know the amount. So find the amount after T equals 0, 2, 5, and 10 years. Now that's the part you're going to love, that calculator, what I'm going to show you. Might be new for some of y'all, might not be. So we'll see. So first of all, they want us to fill out this formula using our data. So we're going to bring down our A of T. The math lab will give you the A of T part. All we got to do is fill in the rest of it, okay? So my principal balance is my starting amount. My starting amount is $57,000. Then we got our parentheses. 1 plus R. R, remember, was 5.5%. I need to turn that into a decimal without the percents. So if you'll turn 1/2, that'll give you 0.5. So this is basically 5.5%. So to get rid of the percent sign, I'm going to move it left twice. So that's going to give me a 0.055. Okay. All right, so that's 0.055 divided by N. So y'all, what was N if it was quarterly?
4.
4, there you go. And then close those parentheses. And then remember up here would be 4 times t. So that's basically the formula. So all we got to do now, y'all, this part that's inside the parentheses, MathLab will count you wrong if you leave it like this. They want you to write that as a 1 point something. So they basically want us to simplify this part. So we'll bring down our 57,000. So on our calculator, let me see if y'all can see this one. I'm going to figure out what 1 plus 0.055 divided by 4 equals. So notice that gives me a 1.01375. So this is going to be 1.01375. And then the exponent will be 4 times t. This is what MathLab wants in the answer, okay? You got to simplify the parentheses down. So now I can put a 0 in and figure out what it is after 0 years. I can put a 2 in for the t, figure out what this equals after 2 years, 5 years, and 10. So let's try that. When t equals 0, t equals 2, t equals 5, and t equals 10. So here's a question. Do you feel like punching all these numbers into this just to get my answers? Because y'all want me to show you the easy way, right? So let me pull up my calculator. So let me clear that off. And I'm going to go y equals and clear that one out there. So, y'all, what I'm going to do, that equation we just came up with, I'm going to put that into my y1. So I had 57,000 parentheses 1.01375 close parentheses, and then we'll put in our exponent. Now, it's 4t in the formula, but in the calculator, you got to put a 4x. Okay, the variable always has to be x when you use your y1. So we could graph that if you want to, but I don't even care about graphing it. I just need that function in my y1. We're going to learn about a new feature on this calculator. You see the trace button up here? Right above the trace button in blue, it says CALC. That means calculations. So watch this. I'm going to hit the second button and the trace button to get calculations. What I want is the value. Value is the first one already highlighted. So hit enter. Now, when you do that, some calculators are slow, but it goes to this screen. It might think just for a second, but then it'll put that x equals up there. So my first x was 0. So watch this. When I put a 0 in there, and y'all, let's see. They want me to round these to the nearest dollar. So when you put that in there, you hit enter. You see that y value? 57,000. Well, that makes sense, right? If you had 57,000 when you started, if t was 0 years, then you still better have that 57,000. Now, I want to go to 2 years. So I hit second calc again, or second trace to get the calculation. Enter for value. This time I'm going to put a 2 in and hit enter. So now rounding to the nearest dollar would be 70,920. All right, ready? Let's do the third one was 5 years. So second trace to get calculations. Enter for value. I'm going to punch in for 5 years and enter. Woo, to the nearest dollar. That's 223. 337. 0.4, that's going to leave me at a 7 on my dollars. So y'all, this is easier than throwing in these numbers, right? So then you would do second trace for calculations, enter for value, put in 10, and enter. Whoa, that's over, let's see, that's like 13 million there. 434. 507. Oh, I see what's happening. I see what's happening. My graph was messed up. Okay, let me go back up here. I see what you're talking about because we don't have 13 million after that many years. I seen that on the, I didn't know what y'all was talking about, Y2 X's, so let me go. I hit too many X's, didn't I? So let me delete that one. All right, I'm sorry, now I didn't see you. I didn't know what that was what you was talking about. So now let's go back and do this the right way. So value is still going to be 57,000 after 0 years. Woo, that started going up a little fast, didn't it? So let me try this. So value for 2 years. There we go, 63,580. Second trace for 5 years. We'll hit enter. Girl, I'm telling you, I'm about to go throw 57,000 on a 5.5% interest, right, for 10 years and get me about 13 million. All right, so this is better. After 5 years, you got 74,900 and oh, it's gonna be 902 this time because that 79 rounds me up. And then how about 10? So we'll do second trace for calculations, enter. So I'm sad this ain't gonna be 13 million, right? It's only going to be 98,000. Oh, we'll make that what, 426 since that's a 9. All right, so don't put too many X's because what it was doing, I think, by putting XX instead of doing 10 years, that thing was doing 100 years because it was multiplying 10 times 10. So guess what? After 100 years, you would have $13 million, okay? Woo, okay. The only other way to do those is just to plug them in your calculator and put in 0 for the X first time, get that answer, just doing it on the front of it, okay? So right here, you could have did what, 57,000, parentheses, 1.01375, close parentheses. And then for your exponent, it would be, what was it, 4 times, so I'll do 10. That was the last one I did. And if you do it that way, you'll still get the same answers. It's just more tedious, I think, doing them by hand. But I wanted to show y'all every feature on that calculator. So that's a feature that I use to do that kind of stuff. All right, y'all. So my last problem of the day. So we're about to see how much money little Melissa has on her 16th birthday. So on Melissa's 6th birthday, she gets a $8,000 CD that earns 6% interest. Compounded semi-annually. So here you go. If the CD matures on her 16th birthday, how much money will be available? Now we'll say, I'm going to teach y'all in chapter 9.7 about what we call continuous compounding. And when we use continuous compounding, we'll replace the stuff in the parentheses with that E I was showing you earlier. All right, so a few things I need to figure out is what my T is. I need to figure out my interest rate, and I need to figure out my N before I throw it in my formula. So T is the time in years. So how many years is my time on this one? From when she gets it till when it matures. Oh, y'all already got that. That's 10 up there. Good job. So time is 10 years. Our interest rate is 6%. We need that written as a decimal. So what would 6% be as a decimal? Oh, you're so close. You know, I add, there you go, 0.06. Remember, move it left twice, okay? So you'll move left twice, which means when you're moving them left, sometimes you got to add a 0 in there to get that second move. All right, last thing I need to know, semi-annually. And that is definitely 2. All right, so let's go. We're going to find A at 10 because T is 10. So the amount after 10 years is equal to her starting amount, which was 8,000, times parentheses 1 plus R, which is 0.06, divided by N, which is 2. All that raised to the 2 times my T, which was 10. So all we're doing is always just plugging into the same formula. Now, since this is just the only formula I need, they want me to round this to the nearest cents. So I'm just going to go to the calculator and punch this in and see what we get. And I probably wouldn't even graph this because I'm just going to punch it in since I only got to do it once. So here's my 8,000. Parenthesis 1 plus 0.06 divided by 2, close parentheses. Now notice to work this, I didn't simplify that because I'm not putting this formula into MATLAB. So let's go grab that exponent by hitting that caret up. And what we have, 2 times 10. Or you could have just put 20 for that exponent, okay? All right, I'm going to hit enter. We're going to round to the nearest cents. So let's see, that is 14,000. So let's see, 448, that's got an 88 after it. So I'm going to change that 48 into a 49. So that's 14,449. Oh no, dang it. I'm not rounding to the nearest dollar, rounding to the nearest cents. And I even told you all that. My bad. All right, so $14,448. My cents is going to be 89 because that 9 kicks that 8 in front of it up. Well, been a long week dealing with this technology and all that. So y'all, that is 9.3. So I don't mind these formulas. You just got to get through the a few sections where you had to do the graphing, okay? And the main thing, I'm going to send out a video in a little bit of showing you all the ones on the homework where you had to graph them and move them around on that math lab, okay? All right, y'all. So any questions over exponential functions? All right, I wanted to remind y'all a few things. First thing, y'all know registration is open, right? So y'all can now choose classes for summer and fall. So y'all, if you're planning on going summer and fall, I would jump on there and start getting them classes because they will fill up quick on you, and you might not get the schedule you want. Okay. All righty, y'all. So test 3 is due Sunday night. I sent y'all videos doing that from Tuesday night. So let's see. I'm gonna stop my share. Oh, y'all, so look for my videos in about an hour or two. I'll have this recording, plus I'm gonna send another video actually doing the math lab part of this. All righty, y'all. So any questions? Y'all realize we don't get to do this but about 3 more weeks, right? After 3 more weeks, y'all's Tuesdays and Thursdays are gonna be sort of boring. Oh, perfect. Yeah. Yeah, that was it. 14,449.89. There you go. All righty, y'all. So we continue on next Tuesday. So I'm going to stop our recording.